The time graphs, okay. This got moved a bit. Okay, write this down please. Velocity time graphs. Whoops. Yep. Okay. You have that velocity time graph? Right, so we'll basically look at the graphs. Just some things to note first. So, in one dimension, a positive number means to the right, and a negative number means to the left. I think I told you that already though, so you know that. Vertically, a positive number means up, and a down is by a negative number. So I think we talked about this already. So therefore, a single number could actually be a vector, because if I said to you 2 meters, or if I said to you minus 2 meters, well, even though it looks like there's no direction, I'm actually meaning to say that it's going to the right, and here I'm meaning to say that it's going to the left because the minus. So it kind of has a direction, okay? But we said that already. So if I said s equals 1 meter, that means 1 meter to the right, and if I said minus 1 meter, that is 1 meter to the left. That's okay? Right, now on to some more formal definitions. So acceleration is a vector, and what exactly is acceleration? It's the change in the velocity. And that's the formula. Now I need to explain that a little bit. So for example, let's say we have our car heading north at 10 kilometers per hour, and then it gets faster, it goes faster, so maybe now it's going at 20 kilometers per hour, and it continues to go faster, so then maybe it's speeding up, and now it's going 30 kilometers per hour. So what's happening here is the velocity is changing. Here it's 10 kilometers per hour north, here it's 20 kilometers per hour north, and here is 30 kilometers per hour north. We call this acceleration. Acceleration.
Because I took it in physics.
Yes?
I do not remember it.
But now you remember it?
Yes.
Okay, good. So the acceleration depends on the change in the velocity. Change in velocity.
Yes.
Yeah. So for example, here, I don't know. We'll call the change here delta V. So what is the change? It got an extra 10. Yeah. And here the change is delta V, and then it's also 10. And maybe it did this over 10 seconds. And maybe here it took it 10 seconds to change its speed. You know. So you need 2 things. You need the delta V, how much the velocity changed, and the delta T, which is how long it took for that change to happen. So as a formula, the acceleration is just the change in the velocity divided by the time it took. The delta V over the delta T. This is the definition of acceleration. Delta V is the change in velocity, and delta T is the time passed. You remember acceleration, yeah? What's the dimension of acceleration? Dimension, not unit, dimension.
MLT minus 2.
MLT minus 2. No.
No. Its velocity is LT minus 2. It's LT minus 1, it's LT minus 2, but not M.
LT minus 2 is the dimension, yeah.
Sorry.
Yeah. You got the mass in there. I think you were thinking of force, maybe. Sorry, just to write it down here, the dimension you can see is LT minus 2, and the unit usually is meters per second squared. Yeah. I didn't write that here, I don't think. Maybe no, I didn't actually. have to add that in. Yeah. Okay, great. Continue?
Yeah.
Yeah?
Yeah.
Yeah? This is the key, the formula. The change in the velocity divided by the change in the time, and its unit is meters per second squared. Right, so a naming convention. For motion, we have different letters for different parts of the motion. So we use the letter U to represent, maybe somebody knows this already. No, the letter U represents the velocity at the beginning. And the V will be the velocity at the end. So U is the velocity at the beginning. Also called the initial velocity. Yeah. V is the velocity at the end, also known as the final velocity. So in my little car example here, this would be the U and this would be the V. Yeah, but if we forget about that part, just look at these two. Yeah, yeah. V is the velocity at the end. Yeah. A, of course, you know, is the acceleration. How much the velocity has changed. T is the time while accelerating from U to V. And S,
The velocity.
no, not quite distance, displacement, the position. That is, where is it at the end compared to the start. Right, so you'll definitely need to write this down. Now you don't need to write it all down. For example, you could just write down U initial velocity, for example.
Yeah.
Yeah, you have that already? Yeah. Have you seen these before, UVATS? No, really? You've seen it? Yeah. But is the idea okay? Yeah. So it starts at U and then it gets faster and finishes at V. This is called the acceleration, accelerating. That is the S in meters, and then the time is the T. But I'll give you examples to help see that. Continuing. So, the example like with Usain Bolt, for example. So, at the beginning, what's his velocity? His U. Zero, and the unit? No, the unit? Meters per second. So at the beginning, it's 0 meters per second. But is it 0 meters per second at the end? No. What is it? Does anyone know? What's his V at the end? Does anyone know? No.
Is it 0 meters per second squared?
No. At the beginning, his U is 0 meters per second.
It depends on his speed.
I was wondering if anybody knows for him.
Yeah, it's particular here is the fastest.
Yeah. So does anyone know?
He has made record this year too.
No, faster than 9.
No.
So the U is 0 and his V, I don't know, it's probably about 15 meters per second. 15 meters per second, maybe 14.6 or something. So that's the U is 0, he starts at rest. The V is about 15 meters per second. Now the T, you know, it's about, what's his T? Oh, you know.
9.
Yeah, so what's it for Usain Bolt?
9.
About
9 point something.
About 9.6
This year,
seconds. Yeah, this year. You know who this guy is, don't you?
Yeah. Jamaica.
Yeah. So about 9.6 seconds is this time to run the S. What's the S for this race?
Speed.
No, the S is displacement, and what's it for this race? 100 meters. So for this, the S is 100 meters. Yeah, and the acceleration, you could calculate it. We don't know it. It'll be quite high. Yeah. So this is an example. So he starts off at u, which is 0. The v at the end is about 15 meters per second. The s is definitely exactly 100 meters. The t is about 9.6 seconds. Okay.
Yes, 9.63.
9.63. Okay. All right. Yeah. Please remember, velocity can be positive or negative. So if it was negative, what would that mean? It's going backwards. Because it's a vector. But speed is only positive. Okay? Also, displacement can be positive or negative. The coffee cup is 1 meter in front, and minus 1 meter would mean it's back here. Yeah? So displacement can be positive and negative, but distance must be positive. Yeah? Do not confuse speed and velocity, please, or distance and displacement. Now, sometimes they're usually the same for most problems, but not always. Okay? You have been warned. This will be your final warning, okay? I'm not going to say it again. We've been warned about this, so please be careful about the signs. Right, now, in a moment we can draw this, but I want to explain this graph which will be drawn. This is called a velocity time graph. On the x-axis is the time, and on the y-axis is the velocity. So, let's look at this story together, because the graph tells a story. We imagine that this is a car. So, at the beginning, the velocity is 0. So that means the car is at rest. It's not moving. Then what happens? It gets some velocity. Here we say it accelerates slowly because it's still going slow and it's not getting much faster. But then what happens here? The velocity suddenly increases. So then we say it accelerates quickly. Now describe what the car is doing for this part of the journey.
It's only the average speed is with
same speed. Yeah. So like for example, maybe it's on a motorway or something, a highway.
Yeah.
Same speed. So it's steady speed. Okay. Then the velocity quickly becomes 0.
Yes.
Because you stop. Maybe you passed something or you saw something and hit the brake and you stop. Now what's happened here? It stopped, it's not moving.
But time is on.
But the time is still passing. Then here you realize, oh, I missed my exit. So then what happens? You start to reverse the car backwards, and now you're reversing backwards on the motorway because you missed your exit. So this velocity time graph, it tells a story of the motion. Okay? So you can see here the car is going quite slow. Maybe because the car is driving on a normal road, and then when it gets on the motorway, then it quickly speeds up, for example. Okay? So the vocabulary here is what I care about. Can you read it? Accelerate slowly, accelerates quickly, steady speed, rapid deceleration. Deceleration. Yes, it's
accelerate and
accelerate is usually slow to fast, and decelerate is fast to slow. Yeah, it's the opposite. Stopped. It's all there in it. So can you try and draw this with the vocabulary? The vocabulary is important here. Yeah, that's okay. Recording, making sure. You got it already, yeah? The vocabulary familiar, or you knew these words, yeah? Is it accelerate a word you would learn in IELTS? It's not really a... It's not really...
Because IELTS was like boring exam.
Yeah. Yeah, you would only really know these words if you did physics before, I think. You're not going to learn them in an IELTS class, I don't think. No? Except maybe steady.
Yeah, I'm going to have Pakistan.
No, I just thought because you took IELTS before, didn't you? Did you do IELTS? Yeah, yeah. Everybody did. Everybody does IELTS, don't they?
But I haven't went to any...
Oh, you're Korean, so you don't need to. Yeah. Yeah.
Exactly.
He's lucky, yeah.
But I gave IELTS, I haven't practiced anything, just go and do it.
Yeah. Yeah. Well, it's just something you have to do, you know. If you're Korean, you don't need IELTS for a visa, is it?
Yeah.
It's nice. Why though? Do you know why?
There must be some relation.
There must be some agreement, yeah.
Like the Indians and the people of China are having agreement that if you are having an Irish visa, then you can go England, or you are having England visa, you can come here. You must be having one visa.
Maybe it's something like that.
Yeah.
English in high school in South Korea must be really good, is it? Because South Koreans...
Grammar is good, but...
No, I don't know. Usually my experience is South Korean students have good English. You don't think so?
Yeah, I don't think so.
I think maybe.
But there, they mostly speak Korean. If you go China, they only speak their language.
Would there be many people speaking English in South Korea?
Yeah. But
Yeah. Like if I went to South Korea and went into a shop and said a cup of coffee, it's okay?
It's okay.
Yeah,
You love
okay.
coffee.
Well, as example. Okay, do you have this?
Yes.
Yeah? Okay. I'll continue. If you missed it, you can get it from the video.
Okay.
Or do you want to take a picture on your phone, or do you want to get the video? You take a picture? Okay. Yeah. People have seen this type of graph before, or is this a new graph? So you put time here and velocity here. Okay? Have you seen it before? Yeah? No? Okay. Alright, continue.
Okay.
Right, so what we want to do is draw this story. A car starts from rest, it slowly accelerates to 20 meters over 10 seconds. It keeps this speed for 5 seconds and then suddenly decelerates, should say, to rest over 4 seconds. Draw the graph. So I think I'll let you... Do you think you can try and draw this graph? Or do you need to see me do this one? Andy, what do you think? Do you think you can try and draw it, or do you need me to do it? You think you can? Give it a try. Who's this now? Connell. Could you ask Mahmood? That's you, isn't it, Mahmood? To send me an email from his email, because the one he's using, Connell, is not working. So can you email Connell after class? That's all you need to do. Send him an email to say, hello, this is Mahmood, this is my email. So, that's all, yeah. You going to do it now? Okay, might as well.
But it works.
Yeah, now.
So do we write the vocabulary in the graph, or do we just...
No, just draw it. That's all I want to see.
Okay.
Yeah.
What's the email for the...
Connell is C-O-N...
C-O-N...
A... L-L...
L-L-E...
At... No, that's it. At... D-I-F-C...
D-I-F-C...
Dublin. D-U...
Dublin is close to
DUBLC or it's like
One word, one word.
One word.
DUBLIN dot
Dot
IE.
IE.
Yep. You can just
So
say,
what is this-
just
the
say
subject like?
hello. Just say hello from Mahmood. He'll understand it. It's okay. Yeah. You drew this? Can I see what you got? Let me see. Yeah. Yeah. Yes. Nice. Okay. No trouble there.
Excuse me.
Yeah.
Mister,
Yeah.
can you say for me the email because I've sent it from the home because like.
Okay. I'll write it here,
Okay.
and then I'll do the question decided.
Okay.
I think it's 2 L's.
Conal, it's 12.
2 L's. Yeah.
I
Okay, now the only problem maybe with your graph is I don't know, did you put the numbers in?
yeah.
Did you? Okay, so what happens at the start? It accelerates from, this is meters per second, and this one is time in meters per second. It starts at 0 and accelerates to
20 meters per second.
20
For 10 seconds.
over 10 seconds. And then it keeps the speed for
For
5 seconds. And then
Then it is.
for how long?
For 4 seconds.
So then it finishes here at 19. Yeah. Okay, that's okay, isn't it? Yeah. So for the exam, oh yeah, you need to write it like this. When you see here, look, I write v/ms minus 1.
Yeah.
That just means velocity in meters per second. And here, for example, this means time t in, what the heck? Nobody spotted that. In seconds.
I was saying.
Yeah, in seconds. Yeah.
Nine.
Yeah. Okay. So when you write these graphs, draw these graphs, the way to do them is like here. It's name/units. Okay. This is not the way we do it in physics. Name bracket units. Okay. No, thank you. This is the way to write it. Okay. What did you use in school? The first or second?
First one.
First one? Anyone else know what they used in school? Did you use a slash or did you use brackets?
We didn't use brackets. No.
Slash?
Yeah.
Okay. Right, is that okay? Yeah? Okay. Continue. Right. Now, we have this triangle, which maybe you remember from middle school, but it's a way to calculate distance, speed, and time. The triangle, called Dad's silly triangle, because the letters are the same as Dad's silly triangle, but it doesn't matter about that. So this is distance, this is speed, or more accurately, average speed, yeah. And this is time. So I'll show you how this works. If you want distance, it's average speed multiplied time. If you want average speed, it's distance divided by time. And if you want time, it's distance divided by average speed. Have you seen this triangle before? Yeah. So you don't need to draw the three of them. You can just draw the first one, please. Okay? Or actually, even just draw my one. Yeah. And I'll call this when I need to reference it, I'll call it the distance, speed, time triangle. think everybody learns this in middle school, even if they're not studying physics. It's like basic science. Yeah? Okay. Continue? Right. So the key thing here, please note, we use this triangle for zero acceleration usually. So, okay, I suppose you can use it for average speed, but I'll just delete average. I don't want to confuse things. We use this triangle when there's no acceleration. It's just moving at a steady speed. Okay? But no, I'll stop talking. Okay, let's have a look at an example here. A boy walks 2 kilometers to school. It takes him 30 minutes to walk his journey. What's his speed? Okay, so we have distance and we have time. I want his speed. So that's what do we do here? What's the formula? Distance, speed, time. So speed is distance over time. So it's 2 kilometers divided by... Yeah, but we should use hours.
Yeah.
So divided by...
0.3. No. How much hour?
0.5. Why 0.5? 30 minutes is half an hour. Yeah? So what's the answer for this boy? It's 4 kilometers per hour. Do you even need to write this down? I don't think so. It's basic, isn't it? Okay. So you may be thinking that a velocity time graph can tell us the velocity at a given time. True, it does. However, it can tell us much more. Let's see. So, this is important. You need to write this down. Well, actually, it's not too much to write, but what is on this axis? Time. And its unit? Seconds. And on this axis? Velocity. And its unit? Meters per second. Now, watch this. If I was to just draw a straight line here, let's say it just goes from here to here. You remember in maths what the slope is? Slope m?
Yes.
It's the formula y2 minus y1 over x2 over x1.
x2 minus x1.
Or, if you might remember from middle school, it's this height divided by this base.
Yes.
That's another way to calculate it. This we call delta y, and this we call delta x. Or in English we call this the run, and we call this the rise, and we call this the run. The slope is delta y over delta x, or the height over the base, or if you want to say the rise over the run. But what's the units? Let's look at what the units are. So what are the units on the top for the y? This here.
It's meter per second.
It's meters per second.
So it will be meter per second.
And the base is seconds. So the slope is in units of
Meter per second squared.
meters per second squared. So it might not surprise you to know that the slope represents the acceleration. That if you calculate the slope, in fact you are calculating the acceleration of the motion.
Yes.
Yeah. Now if you didn't like it like this, you could use the formula. So example, y2 minus y1 over x2 minus x1. But what units are the y's in?
Delta y change.
Yeah. But what unit are the y and y2 in? The y1 and the y2? The y's, what are they in?
Meter per second.
Yes, again, it's meters per second, and the x is in seconds. So again, it's meters per second squared. So the acceleration is represented by the slope. Yeah. So if the slope is bigger, then the acceleration is bigger. But that's not a surprise, is it? And if the slope is smaller, the acceleration is smaller. Now, let's calculate the units for the area. So the area for this is a half delta x multiplied delta y, because what shape is this? It's a triangle. Yeah. What's the units for delta x?
Delta x is
Seconds. And the delta y?
second.
Meters per second. So the area, the unit here is meters. So what do you think that represents? If the unit is meters,
It's the displacement distance.
the distance, the S, the displacement.
Okay.
So this graph reveals all the information. So if I just put the letters in, okay, so let's put it neatly. This one here would be U, and this here would be V. This here would be T, and then this here is S, and then the slope here
A.
is the A. So the U, the V, the A, T, and S, you can see it all on this graph. So to summarize, U is the height at the start, V is the height at the end, A is the slope, the gradient, T is the time, the length of the base, and S is the area under the curve. Or if you want it as a picture like this, you can see them all. So at the very least, draw this, I think is enough. Yeah, I think if you draw it, that's enough. So now we have the extra result that the area represents the S and the slope or the gradient represents the A. So this is now extra. Okay, continue?
Yes.
Yep, okay. Right, so we have one example to do and then we'll finish. So can you carefully copy that table in your book? But just before you do, let me just say what's happening. This is a car.
Yes.
And this is the
time and the
time and the velocity. So at the beginning, the car is at rest, it's stopped. And then what happens? The car gets faster and then slows down and then it's a steady speed. Okay. So if you can copy this table and then we'll answer these questions together.
Yeah. Okay.
One second, let me just... Oops. Just the table, please. You have the table? Yeah? Well, the time is just 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's the velocities that are interesting. 0, 5, 10, 15, 20, 20, 15, 10, 5, 5, 5. Okay. Can I continue? So let's do this one. So part 1 is draw. Okay. Yes, Mahmood? What one are you writing?
Number 7.
Okay. And the last ones are just 5, 5, 5.
Okay, the 3 numbers?
Yeah, 5, 5, 5. Alright. So, we have time and the unit seconds.
Yes.
And we have velocity And the unit? Meters per second. Okay, so let me just copy them down. And the time goes, the time goes up to 10, isn't it? Yeah? Okay. Now, I'm not going to use graph paper because this will make much nicer graph. It starts at 0, 5, 10, 15, 20, 20, 15, 10, 5, 5, 5. Okay, you know how to draw a graph. So let me just make it for you nicely here. Insert a chart. Okay, so here we go. Scatter with the straight lines. Next. So we want to have the title. We'll just call it velocity time graph. Time graph. Carbon motion, I don't know. Okay, the x-axis was time in seconds and the y-axis is velocity in meters per second. So this is what the graph should look like. Nice graph there. So there's 3 questions here. The first one was the distance, the acceleration and the deceleration. So let's do the distance together. How do we calculate the distance?
Speed over time.
Not for the graph. What do we use on the graph for the distance?
For the distance, it's area.
It's the area. So if I want to know how far this car has travelled, I need to calculate the area. Okay? So you need to think about it as a few different shapes. For example, what shape is this? A triangle. So it's a half the base by the height. So a half of 4, 2, by 20 is, multiply by 20, 2 by 20 is 40. So this piece is 40 meters. Now here, what have I got?
This is like
a rectangle. So this is 1 unit, and this is 20 units. So the area here, 20. So this is 40, and this is 20. So we have 60 so far. Now what about this part?
This
Two shapes. Yeah. So first we have this rectangle. That's 3 units. And then the height is 5. So it's 15. So what are we at now? 95?
No,
16 plus 50, 75.
No, it's 75.
75, thank you. Okay, 75. And then we have this triangle.
Yes.
The base is 3, is it?
Yes.
Yeah. And the height is 15. Yeah. So, okay, now we need to start using the calculator. So we're at 75 plus 0.5 multiply 3 multiply 15. What are we at now?
97.5.
Okay, and then finally, this rectangle here, which is 2 multiply 5, which is 10, so plus 10, and we have...
107.5.
So the distance the car travelled is 107.5 meters. Is that okay? Yeah? Now, the acceleration. How can I calculate the acceleration? It's the slope, which is the rise over the run. So what's the rise here? 20, and the run is 40. So 20 over 4, 20 over 4, 5. So the acceleration is 5 meters per second squared. And the deceleration will be 15 over 3, which is
15 over 3.
5
5.
as well.
5, 10.
So this is 5 meters per second squared, or you can say the acceleration is minus 5 because it's going down. Okay, so this is plus 5, minus 5, and the distance traveled is 107.5. Okay.
So we'll write plus minus 5.
Yeah, so I'll write the answers down here. So if you want to be clear about how to write the answers, the distance travelled, or the displacement in this case it's the same, is what do we say, 107.5 meters. the acceleration is 5 meters per second squared, and the deceleration is 5 meters per second squared, which just means that the acceleration at the end is minus 5 meters per second squared. Yeah. So the thing I tell students is when you have the word deceleration, the D already means you have the minus. So you don't need to put the minus again.
It will become a
Acceleration.
Yes, that's it, yeah. So inside the word D is already the minus. Okay, so here, because I don't have it deceleration, I have acceleration, then I need to write in the minus. Okay, so just be careful about that point. Yeah. Right, so you have some homework, of course. So there's 3 graphs I want you to make. Okay, but you have until Monday. Tuesday?
Monday, I think.
Monday. So you have 2 homeworks, the vectors, which is really easy, and then these graphs here, okay?
So we'll follow the same timetable that was given the last week.
Yeah, it should be, unless something needs to change, but I don't think
But
so.
they will inform us.
Yes, of course, yeah.
For the person.
It'll probably be this for all of the semester, yeah, unless we have to change a room because, I don't know, we have to have more classes or something like this. Okay, can I close this?
Yeah.
All right.